Okay, all right. You need this title header, date. These are your formulas. This is part 1 of 2. We're starting with circles. You can pause the video if you need to copy this down. This is going to be part of your notebook test grade, so pause this if you need to. Okay. All right. So we're only going to be writing equations today. We're doing 4 problems in total. So first up is circles. Center of a circle is h comma k. Equation for a circle is this. We talked about this a little bit, but just a reminder, the normal formula for a circle is usually just x squared plus y squared equals r squared, which we've been seeing from the unit circle. But this is a circle whose origin is at 0, 0, or whose center is at the origin. All right. When you get a circle, you should start off by drawing a rough graph. All of my graphs today are going to be counting by 5s, because anything more is just going to be too much work. All right, negative 14 down 5. So this is your center. All right, and then there's a point on the circle that's at negative 10 down 3. So from here, you should be able to draw a rough circle. All right, let's start off by labeling some information. So h is negative 14, right? K is negative 5. What else do we need for this formula? We need r squared, but we'll do that later. Let's start off by just plugging this information in. Instead of x minus h, x minus negative 14, which is plus 14 squared, plus y, instead of minus k, it'd be minus negative 5, which is just plus 5 squared equals r squared. All right, the last thing we need to do to finish this problem is just figure out what r is. You can use the distance formula, but it's easier if you just take these two values and plug them in for x and y, and then you'll be able to solve for r squared that way. So this I'll do in purple. So instead of x, you're using negative 10 plus 14. Same exact equation, just plugging in x. Instead of y, you're using negative 3 equals r squared. We don't know what r squared is. Negative 10 plus 4 is positive 4, plus negative 3 plus 5 is positive 2. 4 squared is 16. 2 squared is 4. 16 plus 4 is 20. All right, we are done here. You don't need to know what r is, because when you plug it into the equation, you're plugging it in as r squared. So this is as far as you need to go. Now we're going to take this original equation that we had before we knew what r squared was and just rewrite it. And that's it. That's how you write an equation for a circle. All right, you're gonna try this one on your own. This is still a circle. You're still writing an equation for a circle. All right, pause the video if you need to. Don't forget to draw. Rough graph. Oof. So let's start going through this answer. Hopefully you pause the video. So start off by drawing your rough graph. Identify your h and k so that it's easy for you to plug into the formula. Solve for r squared by plugging in x, y values. And your final answer should have looked like this. All right. Let's move on to the ellipse. So the ellipse is harder to write an equation for, just in general. The equations are more messy. There's two of them. You have to remember that A is always greater than B. Graphing them are more difficult. This is generally how your problems are going to look, where you've given vertices and co-vertices. I doubt I'm going to give you problems where you have to graph given foci, but just in case, you can always look back at the notes. All right, so let's start off by graphing this. So vertices lie at the end of the max axis, right? So on the longer ends. So again, make a graph that counts by fives or whatever you want. So -2, 5, -2 up 5, -10, 5, -6, 8, -6, 2. All right, it is definitely hard to see here. Maybe it looks different on your graph, but this is a horizontal ellipse. All right, so what do we need to know? We need to know what h is. We need to know what k is. We need to know what which means we need to know what our center is. And we need to know what A is and B. So we have quite a number of things to figure out just with this little graph and this information. All right, how do we figure out what our center is? So our center, you can take either one. You can take either the vertices or the co-vertices, and you're just going to find the midpoint. So -2 plus -10 is -12 divided by 2, -6. 5 plus 5 is 10 divided by 2 is 5. And this will work also with this. -6 plus -6 is -12 divided by 2, -6. 8 plus 2 is 10 divided by 2, 5. Works with either one. So h is -6. K is +5. All right, then your A and your B. Don't forget, this is on your max axis, and this one is from your minimum, your minor axis, I'm sorry, oops. All right, so how you decide to figure this out is up to you. I generally just look at the length of this and divide it by 2, because your A is the distance from the center to one of your vertex, and then your B is from the center to one of your co-vertices. So the length of this entire thing, it starts at -2, it ends at -10. It's a total length of 8 divided by 2, that's 4. All right, B, the height of this is from 2 to +8. That's 6 divided by 2, 3. Look back at your notes if you're having trouble finding out what your A and your B are. All right, since this is a horizontal ellipse, this is the equation we're using. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. When you lay your information out like this, it should just be really easy to plug stuff in. Instead of x minus h, you do x minus -6, which is just x plus 6. A squared, well, a was 4, so a squared is 16. Plus y minus k, your k was 5, so it's y minus 5. And then b squared, b was 3, so b squared would be 9. That's it. Okay. And let's get you guys on your very last problem, which is gonna be, you can abbreviate in your notes, by the way. It's your notes. You just need to make sure you get mostly everything down. All right. Remember to graph these once you get them.